I want to welcome David Hughes to the podium, and thank you guys. He's going to talk about the future of WAN. So pay attention. I think you're going to get some great information. David, please come to the stage. Almost got you. Hey, good to see you.
All right. Well, thank you, everyone. I really appreciate the opportunity to talk to you today a little bit about what we see going on in the wide area network. And yes, you probably noticed I have an accent. I grew up in New Zealand. I studied in New Zealand and Australia. And I took a little bit of a world tour. But in 1994, I ended up moving here to the US. And I joined a company called Stratacom. And I don't know how many of you are around and remember back then, but Stratacom was a pioneer of a new kind of technology for the WAN called frame relay. And at that point, most people had built their WANs with X25 or with private lines, TDM systems. And Cisco, Digital Equipment, Stratacom, and a couple of others got together and came up with this new technology called frame relay. The idea was to make it really easy for companies to build a hub and spoke network. At that point, hub and spoke networks where all the branches were connected into the central site were pretty difficult to build. And frame relay made that much easier. And so what was exciting for me is, I joined Stratacom in '94. I was about 200th employee. And 2 years later, we had 1,500 employees. We'd gone from 75 million in revenue to 400 million in revenue. And Cisco had bought us for $4 billion. And I bring this story up because it's the first instance I saw of the WAN being revolutionized. Every decade or so, the WAN goes through a massive revolution. And so in 1994, most people hadn't heard of frame relay. By 1996, everyone knew what frame relay was. And by 1997, if you hadn't deployed frame relay, people would be looking at you strange. Now, after that, I stayed on at Cisco through the 1990s, and towards the end there, worked inside Cisco on the technology that became MPLS. It was called tag switching at the beginning, and we worked with AT&T on a product called IP-enabled frame relay, which actually turned out to become MPLS. And again, this was another big revolution in the wide area network. And what drove that shift was people wanted not just good hub and spoke communications, but in order to support video and voice communications, IP telephony was really taking off at that time. They wanted to build an easy way to build a mesh and for a carrier to offer mesh connectivity. And that led to MPLS. And again, within a few short years, everyone went from frame relay to MPLS. So you had the same situation, the WAN completely changing, and people being driven by a new use case, in that case VoIP, to rethink the way they built their WANs. Now what's interesting is for the last 15 years, MPLS has been the go-to WAN technology for most enterprises. But at the same time, requirements have been changing. And at Silver Peak, I started the company in 2004, focused on WAN optimization. So we've been in the WAN business, talking to customers about their WANs for a long time. And a few years ago, people began asking us a couple of simple questions. They said, I love what you're doing, optimizing my traffic between data centers, optimizing traffic from the branch to the data center, but I'm beginning to put things in Amazon and Azure. I want to know if you can optimize to those virtual locations that I have. They also began to point out that a lot of their traffic wasn't going necessarily to the data center to apps hosted in the data center or going from branch to branch, but it was going from branch to SaaS service like Salesforce or Office 365 or Marketo. And they wanted to understand what we could do to help them. They were frustrated because the network that they had didn't really match these emerging needs. And so in the illustration, you can kind of see this network, the MPLS network, dragging the traffic from the branches back through a couple of sites, maybe a DC, maybe headquarters, and back out onto the internet. So it's a very indirect path. And you end up with a situation where people are using Salesforce or whatever to download some content at home. It goes fast. They're at work. It goes slow. And often it goes slow because they're sitting here in LA. They're an East Coast-based company. And so their traffic that's destined to the internet gets dragged all the way over to New York, then it goes onto the internet in New York, then it goes back to Seattle where the content might be on the internet. Then from Seattle, it goes back to New York, then comes back onto the MPLS network and gets sent back to LA. And obviously the question is, wouldn't it be much, much simpler if you could just send it straight from LA to Seattle and back again? And that's frustratingly difficult with MPLS. And that's really what's driving people to rethink the way they build their networks. People often ask me, what does Silver Peak do? What does the WAN do? And one of the simplest answers and what the job of the WAN is to connect users to apps. And somehow over the last 2 decades, we've made things really, really complicated. If you look at WANs, it's one of the most complicated parts of the network, an alphabet soup of protocols needed to do something which should be really simple, connecting users to their apps. And when you step back and think about it, that doesn't have to be that complicated. We can rethink the way we build WANs to make it much simpler and focus on those users and their applications first and have the technology subservient to that. So the answer to this problem of how do I carry my cloud traffic, what do I do to optimize my branch to cloud traffic? At first it seems really easy. Well, why don't we just add an internet connection into all of my branches and then take that internet distant traffic and break it out straight at the branch and run it to the SaaS service directly. There are, unfortunately though, a number of key challenges that make that much harder than it sounds. The first is the complexity that's involved in today's WAN. So almost anyone that's tried to take a normal router that's doing MPLS and now add internet and then try to load balance or do anything other than simple active-passive using the internet as a backup will tell you it's actually very, very hard. It's surprisingly hard to get a router and a classic MPLS network to route dynamically some traffic across MPLS and some traffic across the internet. And although router manufacturers have begun to add some features to try to make that possible, it's still very, very complicated because that wasn't what the protocols were originally designed for. So that's holding people back. The second kind of concern people have is around security. So if I'm going to open up all of my branches and let traffic out directly, then I've gone from this situation where I've got a castle with 2 doors, one on my DC and one on my HQ, where traffic's going out. I only have to defend those 2 doors, and I can have a deep security stack at those 2 doorways, so to speak. If I am going to open things up in my 100 or 1,000 locations, I've increased the attack surface of my network, and so that's holding people back. That makes them think, I really don't want to open up the branch and let just anything in and out there. Of course, they could deploy firewalls in all those locations, but that's, for a lot of people, that's more complicated and more expensive than what they want to pay for. Another challenge relative to using the internet is, how do I provide SLAs? So if I'm using the internet, 90% of the time, it is really fast. 90% of the time, it's probably faster than my work network, but 10% of the time, it sucks. And as IT, you're on the hook, not just for making things good 90% of the time. You have to make things good and consistent 100% of the time. And so a challenge that IT has in terms of leveraging the internet is, how do I do this, but still provide SLAs to my organization and deliver predictable, consistent performance to my users, not just great speed and sometimes and then not so good in other times. So these are the kind of reasons that people have had that have held them back from using the internet more aggressively and left them stuck with MPLS. So everybody's talking about software-defined WAN or SD-WAN. And everyone has a slightly different definition of SD-WAN. But at its core, most of the vendors would agree on these few key points. And we see this kind of fundamental definition of SD-WAN as being a foundation to build upon. So the first is the ability to support broadband connectivity, to mix and match MPLS with cable, with DSL, with Metro Ethernet, with wireless 4G LTE connectivity. Basically, being able to build an overlay which lets you use any mix of transports underneath. It's a little bit like how virtualization in the data center let you mix and match servers from different vendors from different generations without having to reinstall all of your apps, migrate all your data every time you move to a new vendor or a new generation of server. In the same way, having a virtualization layer in your WAN lets you mix and match and interchange carrier technology without having to disrupt your WAN. The second kind of fundamental requirement of an SD-WAN is the ability to leverage multiple paths, active-active, to be able to select the best path for a given application. Another key thing about SD-WANs is the idea of zero-touch provisioning. You can take a box, ship it to a branch, have someone plug in power, plug in Ethernet. It's automatically discovered, and you're up and running without any configuration, without anyone typing anything on a device in the remote location. The other kind of common aspect to SD-WAN is that you have an centralized orchestration or centralized management. So everything can be done from one place, one orchestrator. And the orchestrator is the control point, and the individual devices do what the orchestrator says, versus traditional networking, where the golden copy of information resides in all the devices and it's just reflected by the management system. So this change from distributed to centralized is probably the reason why SD-WAN has SD in the title. People often ask me, why is it called software-defined WAN? Why isn't it called hybrid WAN or something else? And I think the SD comes because a lot of the ideas of centralized control came from work that people were doing with SDN in the data center. And people looked at that and said, hey, there's something to learn there that could be applied in the wide area network. We could use centralized control to make it much easier to build a WAN, to make it much easier to enforce consistency across hundreds of locations. The last part, in terms of what does the foundational SD-WAN deliver, it delivers dramatic cost savings. So I'll talk a little bit about an example later on, but typically our customers are seeing at least 50% savings, and in some cases 90% savings when they look at what are they spending on bandwidth before, after, how have the operational costs changed, and what are they needing to do from a CapEx budget point of view. So dramatic cost reductions are possible with SD-WAN because instead of using MPLS as the primary and internet as a backup, you can shift things around. So you're using internet most of the time, you're using MPLS as a backup or for your most sensitive traffic if that's the best network at the time. But the roles are reversed, and so that generates big savings. In fact, our kind of most aggressive leading edge customers are doing broadband plus broadband and dropping MPLS altogether. People often talk about SD-WAN as if it replaces MPLS. I think it is the next generation, and it's where people are going, and within a few years, everyone will be using SD-WAN. But people will still be using MPLS and internet as the transport. So SD-WAN's an overlay, and the underlay remains a mix and match of things that exist today. It's a bit like when you use Google Maps or Waze, the mapping software is finding the best path from A to B, but it's not the roads. In the same sense, SD-WAN is all about having an overlay which finds the best path for data from A to B, but it's not the roads. The roads are the internet, the roads are the MPLS network. So you can think of SD-WAN as a technology which augments MPLS and the internet. So is SD-WAN the be-all and end-all? For building a WAN, we think that SD-WAN is a foundation. You need to have that. If you're looking at a next-generation WAN, it needs to be based upon SD-WAN. But there are other very important factors to consider when you build a wide area network. And we see 4 categories. The first category is performance. So I want to be able to deliver that consistent user experience regardless of whether the traffic's going over MPLS or over cable or over 4G LTE. Regardless of what's going on the internet on a particular day, I want things to perform. And in order to do that, it's important not just that you can select the best path at any time, but that you can combine and use multiple paths together, bond them together to provide very high availability links. And one of the key technologies and key differentiators we have at Silver Peak is this ability to bond multiple links together and use error correction, forward error correction, to correct for lost or dropped packets. So we can take two links that are suffering loss or brownout, and by joining them together into a bond and doing error correction, we can deliver private line-like performance over those pair of links. And so it's this kind of technology which lets you deliver on those performance guarantees. The other aspect of performance comes back to our heritage in WAN optimization. WAN optimization is obviously now a mature technology. It's not needed for every app, and it's not needed in every location. But for most customers, there are still apps that work terribly over the wide area network, and there are still some locations that are far from headquarters where WAN optimization is required. And so while we don't lump WAN optimization into the core foundational SD-WAN requirements, we do think it's really important when people consider SD-WAN solutions that they look at how they're going to provide WAN optimization, not for all of their traffic, but just for the traffic that needs it. And so one of the really interesting things that we've done with our SD-WAN offering called EdgeConnect is have this component called Boost, which lets you buy WAN optimization by the megabit enterprise-wide. So you total up the amount of WAN optimization I need across all my sites, and then you can put some here at this site, some here, some here. You can move it around based on the time of day if you want, but you're only buying as much as you need. You can apply it just to certain apps and not to others. And so it makes it much easier and cheaper for you to consume that WAN optimization capability than it has been in the past, where deploying WAN optimization meant deploying a WAN optimization appliance in each of your locations. So moving on from performance to visibility and control. Visibility and control are really important because if you think about it, one of the things you want to be able to do out there in a branch is choose which traffic do I take direct to net, to the internet, and which traffic do I bring back to headquarters or the data center to look at more carefully. And some of the solutions out there today just break out all internet traffic. And that's usually not what people want to do. Usually people think about internet traffic falling into several categories, and often three. And the first one is business apps. So that's my Salesforce, my Marketo, my Workday, things that I know my people at work need to get their work done. And so I want to prioritize those apps. And if it's best to take them direct to net, I want to do that. If there's a faster path through my WAN to that provider, I want to use that. But basically, I've got a policy there for how I handle my business apps. The second category of apps is what I call home from work instead of working from home. So this is when people are browsing Facebook, using Gmail, watching YouTube at work. Now, in today's day and age, most companies allow that. It makes people more efficient if they can do a little bit of home from work. Those websites, you know what they are. You know Facebook, you know Yahoo. So this is traffic. You understand what it is, and you're probably okay taking that direct to net. You can whitelist those sites that are well known. The third category is everything else. So traffic from countries that you don't do business in, traffic going to and from websites you've never heard of. That traffic you probably want to put through your full security stack. You want to bring it back to a regional data center or your central data center or to a cloud provider and go through a full security stack. So if you want to do this, if you want to be able to split your traffic, internet traffic, three ways, you need to be able to tell not just that this traffic is TCP, that this traffic is HTTP, that this traffic is SSL on port 443. You need to know which website or which service it's using. Now, traditionally, that's been done by waiting for a few exchanges backwards and forwards, a SYN going backwards and forwards, and HTTP GET going across, and seeing in the GET what URL the person is after. That's good from the point of view of collecting stats, and it will work for a firewall application. But in SD-WAN, if you're trying to steer traffic, if you want to send it out this way and NAT it out direct on the internet, or you want to bring it to your headquarters and NAT it out through the headquarters, you've got to make that decision on the first packet. You've got to make that decision on the SYN packet, which has no URL in there. And so a lot of what we've done at Silver Peak in the area of visibility is work on new application classification techniques that let us determine what kind of internet traffic something is on the first packet so that we can make one of these steering decisions to either whitelist it and hand it direct to the network, or to bring it back to a Palo Alto or Checkpoint or Fortinet security stack in a regional or central location. That brings us, and I'm kind of overlapping onto the third bullet there of security. Security is really, really important when you're using the internet. So first of all, we have, by default, our devices in a hardened mode where the only traffic that will go in and out of your location is 256-bit AES encrypted IPsec tunnels that run between our devices. Nothing else will go in and out. And then from there, you can decide which traffic you want to whitelist, which traffic you want to let in and out. One of the important things here in this bucket of security is that at Silver Peak, we're not trying to do everything. We want to work with partners, but we're not trying to be a security company. We want to be the traffic steering company and be able to service chain in those partners for a full security stack. The last piece that we see as being important for SD-WAN is being extensible. So the SD-WAN is a revolutionary technology, and certainly some of the other vendors, if you wanted to rip everything out and start again and build a greenfield network, they have a solution there. And so does Silver Peak. But we believe it's really important to be able to fit in and make it really easy to migrate to this new world of SD-WAN. We want to be able to interoperate with existing routers, support existing protocols like BGP and OSPF. We want to be able to run in any virtual or cloud environment. So be it Hyper-V, be it KVM, be it VMware or Zen, be it running in Azure or running in Amazon or running in vCloud Air. We also want it to be extensible from the point of view of being scalable, being able to go from very small sites to very big sites, all in the same framework. And the last piece of extensibility is very flexible service chaining, so that you can say, from a business intent point of view, that this traffic you want to chain through these UTM services, and that's all you have to say. The orchestration takes care of the rest. So where does this end up? One of the things SD-WAN gives you, apart from lots of savings, is much greater agility. And one of the stories I like to tell here is a customer that has recently done some public announcements with us called Service King. So they're a collision repair company based here in the US. And their business model is to acquire mom-and-pop collision repair services, bring them into the fold, and then because they have 300-plus locations, they can negotiate much better deals with the insurance company, with the part manufacturers, with the car companies, and drive efficiencies that it's really hard for mom-and-pop to do. When they acquire these mom-and-pop stores, in order to get them onto their IT systems, historically, they needed to get MPLS into those locations. And so it would take 1 to sometimes even 3 months to get the newly acquired businesses onto their core IT network. And during those 1, 2, 3 months, they weren't able to realize the productivity that they get from their centralized systems. Now, what they did realize is that every one of these body shops that they acquired had internet already. And so they were really excited when they learned that we could provide them a solution where they could get up and running in one day. Basically, using whatever internet was already there, they could build a virtual Silver Peak Edge Connect overlay and be up and running on their Service King IT systems in a day instead of in months. And so that was a huge savings for them, a huge advantage in terms of agility. Now, of course, they saved a bunch of money as well. It was far, far cheaper to go with our EdgeConnect solution than it was to continue with their MPLS provider. But I think that often people get caught up in those bandwidth savings when, in many cases, the agility, the ability to speed up your ability to make adds, moves, and changes is just as important. So, what's important about Silver Peak's solution? How are we different? One is that we are a single integrated solution. So we do SD-WAN, but we also take care of performance. We take care of application visibility and control. We're building a rich set of security partnerships, and we're making the product extensible. We let you deploy non-disruptively today using an overlay. And I think that our ability to make sure that things are secure from edge to edge, that we keep things simple. We are enable you to segment traffic across the WAN to keep the Internet of Things, sometimes called Internet of Threats traffic, separate than your business apps, separate than your employees doing home from work. So, the title of the talk, when I was asked to do it, was The Future of the WAN. And I think that in the next couple of years, the future of the WAN is SD-WAN, software-defined WAN. But people often ask me, hey, it's great that you're way out in front with software-defined WAN, but when you look in your crystal ball, what's next? And so I thought I'd finish with the last slide here on, what do I see coming after SD-WAN? So the answer is SD-WAN. Now, okay, what do I mean by this? Well, it's a play on words. So the SD in SD-WAN stands for software-defined. And as I said before, no one really knows why, but perhaps it's because some of the ideas were borrowed from the data center. But in the future, this SD-WAN means something different. It means self-driving. And I had a meeting with our engineers a few months ago, and they asked me what was next. And I just put up a slide with a picture of a Google self-driving car. And I told them, no, we're not like Uber and Google and Apple. We're not going to build electric self-driven cars and have a service that puts Uber out of business. That's not what I mean by self-driving. But what I do mean is when you look at the movement of self-driving cars, there are some really interesting things going on with machine learning, with artificial intelligence, with not just learning in the car, but also fleet learning, where all of the cars are giving information back into the cloud and then sharing that information back out in a consolidated form. So there's many, many things that are happening with self-driving that you can apply in networking. And so when I step back and look at things, when you kind of look at the last few decades, the start of networking was with the CLI. The CLI is manual, it's error-prone, it's per device. And probably 2 decades ago, people started moving from the CLI to using a GUI and to having some kind of management system that made it a bit simpler. Now, in most cases, this made common operations simpler, but you still always had to keep falling back to the CLI. The other thing is that in this case, it's still a human doing everything. So when you need to add a new site, you're still going to their GUI, you're dragging and dropping lots of things. There's a lot that a human has to do. It's still actually error-prone. Even though there's templating, you may apply template 2B on this day, then in a week when you do something different, you can't find 2B, but you can see this something you saved with version 2C, so you think, okay, I'll apply template 2C. Before long, every branch is different. You've got branches like snowflakes that look the same, but are actually all different when you get up close, and that drives up IT costs. So one of the main things that you get with SD-WAN, as in the software-defined version, is automation. You get automation that makes sure that the same thing's done in every location. And it's zero touch, so that you don't have a big overhead in terms of bringing sites up. So that's what the software-defined that we're doing now is all about. Self-driving brings 2 new characteristics. It brings autonomous. This means that the network's able to make decisions that are human without a human involved. It's also adaptive, which means it's looking at what's going on and making adjustments to things much faster than a human would be able to do. And we're right at the very cusp of this. We have some of the features in our product around how we select paths, where we're monitoring loss, we're monitoring latency, we're adjusting our fault error correction algorithms based on what we learn. And you can think of that as the beginning of this self-driving capability. But what I anticipate, and this is like over a 3 to 5 year time frame, is that a lot of the deep learning and AI advances that have been made in areas like self-driving cars are going to be applied in the network and make the network run itself, have it make intelligent decisions, offload you guys so that you can get on with really adding value to the business with new initiatives versus chasing around intermittent problems in the wide area network. Okay, well, thank you so much, everyone, for your time and attention. I'm really glad that I could be here.